Hello everyone, I'm Nicolò Cacocciola, PhD candidate in electronic engineering. I show to you my work, which consists in the design and building of a platform for the dynamic culture of lung epithelial cells, which also allows to carry out biosensing on the culture itself through an array of organic electrochemical transistors, in order to monitor physical, chemical and biological phenomena that occur during its growth. Dynamic cell cultures have become increasingly important in the last 10 years. They are a type of technology which tries to recreate as faithfully as possible the physiological conditions that the cellular tissue will find in an organ it comes from, trying to break down the barrier between an in vitro and an in vivo cell culture. It is also necessary to create a biosensing system to locally monitor the dynamic cell cultures. In this work, OECTs, namely organic electrochemical transistors, has been fabricated. These devices work in electrolytic solutions, within which it is possible to modulate the current flowing between the source and the drain electrodes by acting on a gate potential. Upon proper gate functionalization, it is possible to correlate the current variations with phenomena occurring inside the electrolytic medium. The cell culture system consists in a sealed chamber inside which the pressure is cyclically increased and decreased, trying to imitate the human respiration rate. The chamber was designed and then manufactured with a numerically controlled milling machine, and a dedicated control electronics were developed. Fundamental tests were then carried out on the tightness of the chamber, on the repeatability of the pressure cycles, and on any temperature variation induced by the system inside it. The OECTs were designed and then manufactured in a clean room. First, the interdigitated source and drain electrodes were made by evaporation of titanium and gold on a silicon substrate, and then patterned by liftoff. The active material of the devices was then deposited by spin coating and patterned by photolithography techniques on the interdigitated electrodes. It consists of a mixture of two ionomers, which takes the name of P.PSS. The devices thus obtained were then assembled in a case that contains the fluidics for the insertion of the electrolytic solution and were finally tested. In the graphs, we can see an example of transfer curves and transconductance curves of the devices, obtained using a 0.1 molar sodium chloride solution and a gold gate electrode. Preliminary biocompatibility tests were performed, growing cell cultures of human epithelium and fibroblasts inside the culture chamber over 72 hours. As a result, the cultures showed identical proliferation to the control ones outside the chamber. The OECTs were also tested using RPMI 1640 cell culture medium as an electrolytic solution, which proved to be suitable for effectively modulating the current flowing between the source and the drain electrodes. Furthermore, pH change tests were carried out in the culture medium, dipping the device in it over a week and carrying out absorption spectroscopy every 24 hours. Again, no change were observed with respect to the control experiment. In conclusion, this work showed that the culture chamber is biocompatible and the UCTs can work with the cell culture medium without changing its pH. Tests with human alveolar epithelial cells and adenocarcinomic human alveolar epithelial cells are planned in the near future. Gate electrode functionalization tests are also planned to pave the way for biosensing. Thank you for your attention.